We were summing from k is p to infinity. Check your dad is calling.
Hello?
But go and pick the call from your bedroom, please. K factorial gamma of k minus p plus 1 x over 2 raised to 2k plus p minus p. And then we wanted to do some shifting. So we set k minus p equals to m. K is equal to m plus p. If we wish to sum over m, then we need to determine the limits. M is k minus p, but k is running from p to infinity. So we need a value for m corresponding to k equals p, as well as the one corresponding to k equals to infinity. When k equals to p, then m is k minus p. This will be p minus p. M will be 0. When k equals infinity, what will be our m? M will be infinity minus p, a very big number minus something. What will be m? What is the value of m?
Infinity.
What is infinity minus p?
Infinity.
So let's transform. Our j minus p of x is the summation we are summing over m. M is running from 0 to infinity. Minus 1 raised to power k. But what is our k using the transformation?
M plus p.
M plus k. M plus p divided by k factorial. What is k?
M plus p.
So we have m plus p factorial. What do we have here? Gamma of k minus p plus 1. What is k minus p?
M.
So m plus 1. We have x over 2 raised to 2k minus p. Our k is m plus p, so 2 plus m minus p plus p. Let's simplify this. J minus p of x equals summation from m equals 0 to infinity. We can split the minus 1 to the m plus p. Before using loss of indices to add the powers, we had something like minus 1 power m times minus 1 power p divided by m plus p factorial gamma of m plus 1 x over 2 raised to, if we distribute the 2 in the, let's distribute the 2 into m plus p minus p. You have 2m plus 2p minus p. What do we have? Okay, let me just write 2m plus 2p minus p for you to see what is happening. This is equal to summation from m equals 0 to infinity, minus 1 to the m, minus 1 to the p, divided by m plus p factorial gamma of m plus 1 x over 2. What is 2m plus 2p minus p?
2m plus p.
2m plus p. Let's factor out the minus 1 to the p. Let's have it outside the summation sign. Minus 1 to the p. Summation from m is 0 to infinity. Minus 1 to the m divided by m plus p factorial gamma of m plus 1 x over 2 raised to 2m plus p. I want you to apply the relation between the factorial function and the gamma function to the denominator. So I want you to express m plus p factorial in terms of the gamma function and also express the gamma function in terms of the factorial function. So I want you to tell me what m plus p factorial equals in terms of the gamma, and then we want to express this gamma of m plus 1 in terms of the factorial. What is m plus p factorial in terms of the gamma function?
Gamma of m plus p plus 1.
This is gamma of m plus p plus 1. What is gamma of m plus 1 in terms of the factorial?
M factorial.
M factorial. So let's substitute these values. This implies we are having minus 1 to the p summation over m running from 0 to infinity minus 1 to the m divided by gamma of m plus p plus 1 times m factorial x over 2 to the 2m plus p. Suppose we use k instead of m. K and m are just dummy indices. If we replace k with m with k, then we have minus 1 raised to power p. Summation from k is 0 to infinity minus 1 raised to power k, gamma of k plus p plus 1, k factorial, x over 2 raised to x over 2 raised to 2k. Teddy bear, mnapaka sanitizer. What happened? What is it? Raised to 2k plus p. But what is this quantity? The summation from k 0 to infinity. What is it? What is this quantity?
JP of x.
JP of x. In other words, j minus p of x can be written or can be given as minus 1 to power p jp of x. We now wish to investigate the cases. P is either an integer. P is either not equal to an integer. P can be equal to an integer. P can also be just equal to 0, though that still belongs to the case of integers because it's from minus something, 0, all the way up to the positives. So we need to investigate those cases. Let's start with what happens when P is equal to 0. We have that JP of x is given as summation from k is 0 to infinity minus 1 to the k divided by k factorial gamma of k plus p plus 1 times x over 2 raised to 2k plus p. So when p is 0, then we are looking at j0 of x will be given by summation from k is 0 to infinity minus 1 raised to power k divided by k factorial gamma of k plus p is 0, so plus 0 plus 1, just gamma of k plus 1 times x over 2 raised to 2k plus p. P is 0, so it's raised to 2k. J0 of x will be given by this. So we can obtain the first few terms and then determine and give the series. So let's substitute the different values of k. J0 of x is given by summation from k is 0 to infinity minus 1 raised to power k over k factorial gamma of k plus 1 times x over 2 raised to 2k. So if we take k equals 0, what do we get? Or let's expand this series summation. You can either say When k is 0, you have minus 1 raised to 0 divided by 0 factorial. Gamma of 0 plus 1 is 1. X over 2 raised to 2k. K is 0. What do you get? Anything raised to 0 is 1, right? 0 factorial is 1. Be careful. Do not confuse 0 factorial for 0. 0 factorial is equal to 1. Gamma of 1 is 1. X over 2 raised to 0. Anything raised to 0, you get 1. So the first term will be given by 1. When k is equal to 1, what do we have? Minus 1 raised to power 1, divide by 1 factorial, gamma of 1 plus 1 times x over 2 raised to 2 times 1. This is minus 1 times x over 2 squared divided by 1 factorial is 1. So divided by factorial. What is gamma of 1 plus 1? We can express this in terms of the factorial function.
1 factorial.
1 factorial. When k is 2, we have minus 1 raised to power 2 divided by k factorial, 2 factorial, gamma of k. So gamma of 2 plus 1, x over 2 raised to 2 times k, 2 times 2. If we simplify this, minus 1 squared gives us positive. So we have positive x over 2 raised to power 4 times 1 over 2 factorial. Gamma of 2 plus 1 is the same thing as 2 factorial. We can obtain a value for k equals 3 and then stop there. For k equals 3, we'll have minus 1 raised to power 3 divided by 3 factorial, gamma of k plus 1, gamma of 3 plus 1, x over 2 raised to 2k, 2 times 3. This is minus 1 power 3 will be minus, so we'll have minus x over 2, the whole thing raised to power 6 times this quantity here. 1 over 3 factorial, gamma of 3 plus 1 is the same thing as 3 factorial, so times 1 over 3 factorial times 3 factorial. So we are having j0 of x equals to, the first term was 1. What was the second term? What is the second term? For those who are following.
X over 2 squared.
X over 2 squared.
Yes.
This is x over 2 raised to power 4 times 1 over 2 factorial squared. This is times, the second time is times 1 factorial squared, but 1 factorial is 1, so 1 squared is just 1. No need to write it. Minus x over 2 raised to power 6 times 1 over 3 factorial squared. And so on. So when investigating the case where p is equal to 0, we get j0 of x is given as this. We can obtain values, different values for j0, starting with x equals 0. X equals 0 would imply j0 of 0. It will be given by 1 minus 0 over 2 squared plus 0 over 2 cubed plus all the way, minus 0 plus 0 and so on. So j0 of 0 is equal to 1. j0 of 0. j0 of 0 is 1. We can obtain j when x equals to 1. We can obtain j0 of 1 Plug in the value x equals 1 in the formula for J0. What do you get? Maybe we can leave it at that point. I think we're overdoing. We can check J1 of x. In the formula for JP of x, substitute P with 1. What is J1 of x? Summation from k is 0 to infinity. Minus 1 power k, k factorial, gamma of k plus p plus 1. P is 1, gamma of k plus 1, plus 1. X over 2 to 2k plus p, that is 2k plus 1. Take a few values corresponding to k equals 0, say 1, 2, 3. Check the pattern. When k is 0, what do you have? Whose fruit is this? Not yours. Am I still in the meeting? You know, I could be logged out unknowingly.
Yes.
I need the feedback. What is J1 of x? Plug in a few values of k. K is 0. When k is 0, you have minus 1 power 0. 0 factorial, gamma of 2, x over 2 raised to power 1. So what is the first term?
X over 2 power 1 for k is equals to 0.
So J1 of x is x over 2. That's the first term. The second term? When k is 1? Paul, when k is 1, what do you get?
Negative 1 over 2 times x over 2 cubed.
When k is 2?
Um, 1 over 6.
Positive 1 over 6.
Yes. X, and then x over 2 power 5.
When k is 3?
Negative 1 over 24. X over 2 power 9.
Is it 9 or 7?
4 times 2. It's 4 times 2 plus 1, so 9.
Is it k equals 4 or k equals 3?
7.
Oh, 7, sorry.
What is J1 of 0?
Zero.
J1 of 0 is 0. What is J1 of 1? Oh, the series continues, so you should have a plus dot dot dot. We've only taken the first few terms. What is J1 of 1?
Are we rating the first few terms individually?
Sorry?
Are we rating the terms individually, like a half minus, and then minus, you continue?
Yeah.
So it's a half.
But you're plugging in the value of x equals 1. So substitute x
Yes.
equals 1. Just simplify that in the calc and give me the final answer. Anyways, in general, you should get 0. So we have J0 of 0 is equal to 1. But J1 of 0 is equal to 0. An important property of the Bessel function is Jp of x is equal to 0
Zero is equal to.
for p not equal to 0. Now we can look at j half of x. So we're first dealing with the case where p is not an integer. Or in other words, we're dealing with a case where p is a fraction. So let's look at j half of x. We can obtain the results for j half, and then you should be able to, go obtain results for j3 half, and so on. J half of x, substitute p equals a half in the formula. My screen is misbehaving again. Jp of x is -1, summation from k is 0 to infinity, -1 raised to power k over k factorial, gamma of k plus p plus 1, x over 2 raised to 2k plus p. P equals a half would imply j half of x is the summation from k is 0 to infinity, -1 raised to power k over k factorial, gamma of k plus p is a half, so plus a half plus 1, times x over 2 raised to 2k plus a half. This is the formula we use to obtain j half of x. So we need to plug in a few values of k, then see the series we come up with. think I can write down k equals 0. We will have minus 1 raised to power 0 divided by 0 factorial. Gamma of 0 plus a half plus 1 is gamma of 3 over 2. Okay, let's just write gamma of a half plus 1. Times x over 2, 2k plus a half. 2 times 0 plus a half. This is raised to power half. So this is positive 1 over gamma of a half plus 1 times x over 2 raised to power half. When k is 0, when k is 1, we have minus 1 raised to power 1 divided by 1 factorial gamma of 1. Is it gamma of 5 over 2? X over 2 raised to 3 over 2. Is this what you get?
Yes.
When k is 2, I think we can stop at k equals 3 and then write down the terms. When k is 2,
Negative 1 squared over 2 factorial.
gamma of
7 over 2.
x over 2 raised to 7 over 2, right?
Yes.
Let's list down the first few terms. What did we have for the case k equals 0?
Sorry, it's 5 over 2.
5 over 2.
Okay, no. For k is equals to 2. We have x over 2 power 5 over 2.
X over 2 raised to power 5 over 2. Okay, for k equals 0, do you have the right thing?
Yes.
1 over gamma of 3 over 2. Let me just write it here. 1 divided by gamma 1 over gamma of 3 over 2 x over 2 raised to power half. For k equals 1,
It's correct.
gamma of 5 over 2. For k equals 2, what are we correcting?
The x power 2 power 5 over 2.
Power 5 over 2, okay. So let's list down the first few terms.
Sorry, may I ask how we got to 5 over 2?
Should be 9 over 2.
What is the formula? Use the formula for j half of x. What is the formula again?
For the last part of the formula is x over 2 power 2k plus a half.
So when k is 0, you have x over 2 raised to 2 times 0, it's 0. So 0 plus half is half. When k is 1, 2 times 1 plus a half. 2 times 1 is 2 plus a half. 2 plus a half should give us 5 over 2. So the second term should have 5 over 2. Paul, are you able to see that?
Yes, yes.
Supposed to be 5 over 2 here. For k is 2, 2 times 2 plus a half.
9 over 2.
9 over 2.
So for k this is supposed to be 9 over 2. I think we can now list down the first few terms. Listing the first few terms, what do we have? J a half of x equals 1 over gamma of 3 over 2 times x over 2 raised to power half minus 1 over gamma of 5 over 2 x over 2 raised to 5 over 2 plus 1 upon gamma of 7 over 2 x over 2 raised to power 7 over 2 plus so on. When looking at the gamma function, I want to believe you came across this beautiful result. Gamma of a half is equal to square root of pi. If you look at our series, we are having gamma of 3 over 2, gamma of 5 over 2, gamma of 7 over 2. So eventually, with some manipulations, we can end up with gamma of a half. We only need to use the formula for the definition of gamma of x. Using definition for gamma of n plus 1, gamma of n plus 1 is n times gamma of n. So we can go back to our series and try to rewrite our gamma of 3 over 2 in terms of gamma of something plus 1. So let's start with the first one. We have, for the first term, we are having gamma of 3 over 2. We can write it as gamma of something plus 1. 3 over 2 in terms of something plus 1 should be a half plus 1, right? Using the definition for gamma of n plus 1 is equal to n gamma of n. This can be written as a half times gamma of a half. Are you guys able to see?
Yes.
For the second term, we have to evaluate gamma of 5 over 2. But we have to rewrite this. How can we write 5 over 2 in terms of something plus 1?
The gamma of 1 plus 3 over 2.
3 over 2. So we start with 3 over 2 plus 1 so that it can conform to the formula. So it's gamma of 3 over 2 plus 1. Using the definition for gamma of n plus 1, we say this is 3 over 2, gamma of 3 over 2, right? Gamma of n plus 1 is equal to n times gamma of n. So gamma of 3 over 2 plus 1 is 3 over 2 times gamma of 3 over 2. But in our first step, we just calculated gamma of 3 over 2. So this is 3 over 2. We use the results for gamma of 3 over 2. And this is a half times gamma of a half. But again, we have the result that gamma of a half is equal to square root of pi. So this is a half into you guys remember how to arrive at that result? Did you look at the beta function? Because you use the beta function to derive that result.
Yes.
Although we don't have enough time to go through that, so just accept it as gospel truth. So we'll have 3 over 2 times a half times gamma of a half. So that is square root of pi. For the third term, we have gamma of 7 over 2. Let's just give it before we proceed to use the result gamma of a half. So we look at gamma of 7 over 2. Write it in terms of something plus 1.
One plus 5/2.
5 over 2 plus 1. So this is 5 over 2 times gamma of 5 over 2. But in our previous step, we have gamma of 5 over 2. This is 5 over 2 into 3 over 2 into a half into gamma of a half. So if we use this result, use the result gamma of a half is equal to square root of pi. Then let's rewrite our series. You tell me what to write. The first term becomes
15 root pi over 8.
what rumors were you saying? You can also factor out what is common. Is Calvin in the meeting today?
Yes.
What do you get?
15 over 8 root pi.
15 over 8 root pi.
For this final term.
Oh, you're talking of the final time. I asked about the first term. I was just wondering where are you guys getting 15?
Okay. Could you scroll up?
I thought you guys were following, so I was expecting you guys to, This is a half times gamma of a half, but this is square root of pi. So this is 3 over 4 times square root of pi. If we use the first few terms and then we use these expressions, let's just write them down first, then try to factor out what is common. What was the first term again?
Root pi over 2.
What are you getting root pi over 2? What was the first term?
Is it the first term of j half of x?
Yes, yes.
The first term is a half of gamma of 3 over 2.
It's x. But what is gamma of 3 over 2?
Okay, root pi over 2.
A half times square root of pi. We can leave it as square root of pi because it's common to all the terms, so we can factor it out. Second term,
1 over gamma of 5 over 2.
but what is gamma of 5 over 2?
3
3
root
over 2
pi over,
square root of pi
yes,
times x over 2 raised to
5 over 2.
the third term,
You have 1 over 2 factorial gamma of 7 over 2.
we had some ratios 5 over 2, 3 over 2, root pi, x over 2 raised to 9 over
9
2,
over 2.
plus, and so on. Factor out what is common.
Okay, the first term was x over 2 raised to power half.
Power half, yeah. So all the terms contain an x over 2. So the first one is x over 2 raised to half. The second is x over 2 raised to 5 over 2. Then x over 2 raised to 9 over 2. X raised to some power is common. X over 2 raised to actually some power of x. What do we factor out? What is common between a half, 5 over 2, and 9 over 2? So it has to be a half, right? I'm trying to factor out what is common in the numerator. X over 2 raised to power half is common, right?
Yes.
So we have an x over 2 raised to power half. If we factor this out, what do we have inside? For the first term, we have 1, right?
Yes.
For the second term, we factored out an x raised to a half. So we remain with x raised to,
5.
is it 5? 5 over 2 minus half? 4, right?
Yes. 2, 2, 2. 5
So
over 2
x
minus
raised to 2. So we remain with x squared, right? Okay, let me write the denominator for the, we will do what we got to do. We will factor out what is common in the denominator as well. So 1 minus x raised to 2, so that when you combine x squared and x raised to a half, you get x raised to 5 over 2. For the third term, what do we have?
Okay, for the second term, it should be x over 2 squared.
For the third term,
X over 2.
X over 2 power 4.
the denominator, what is common?
half pi, a half root pi.
Half root pi. For the first term, what did we have? So we have 1, right?
Yes.
For the second term,
3/2.
3/2. We have 3/2. Are you guys
Yes.
following? It's for your own good.
Three over two.
Let's just factor out what is common in the numerator and the denominator in a single step. X over 2 raised to power half times 1 over square root of pi the half which is common in the denominator. 1 divided by a half root pi. So 1 divided by a half. If we bring the half to the numerator, we'll have a 2, right?
Yes.
So let's just have that 2 here. So what do we have inside?
1 minus
1 minus
2 over 2.
Am I confusing you guys? It's just algebraic manipulations. You have a few terms of j half of x. You want to factor out what is common.
It's just 1.
It's 1.
Yeah.
For the second term,
Second term is 3/2.
X over 2 squared over 3 over 2.
but we've factored out the 2. It's somewhere in the numerator. So you'll have some 3 times 2, right? You have an x squared, you said over 3 over 2, but that 2 is here.
No.
The answer we got for the gamma operation was 3 over 2 times a half root pi.
So what do we have here?
It's 2 over 3.
2 over 3. Is it 2 over 3 or 2 over 3 factorial?
It's 2 over 3.
2 over 3. Is the first term 1 or 2? So
One.
2 over 3,
The first term is 1.
it's 1. The second term,
2 over 3 times x over 2 squared.
X squared?
It's
You have
x
to do
over 2
this.
squared, the whole of it.
So 2 squared.
Yes.
The third term?
We have x over 2 power 4 times 2 squared over 3 times 5, so it's 15.
Simplify. Tell me what to write. A single expression.
4 over 15. 4 over 15. Over 15.
What do you have as the third term?
2 over 15 into x power 4 over 2 power 4.
I don't want that over 2 power something again. I don't know. Simplify everything. You cannot have 2 denominators. That's what I... Okay. They're not giving me the right answer. That's why
X power 4 over 6.
when you factor out x over 2 raised to power half times 1 over square root of 2, this is what you should get. 2 minus 2 over 3 factorial times x squared plus 2 over 5 factorial times x power 4 minus 2 over 7 factorial times x power 6, and so on. Factor out the 2, get x over 2 raised to power half times 2 raised to square root of 2 into have 1 minus x squared over 3 factorial plus x power 4 over 5 factorial minus x power 6 over 7 factorial, and so on. X power half, x over 2 power half, we can write it in terms of the square root function. This is square root of x divided by square root of 2 times 2. This is square root of pi, sorry, divided by square root of pi into 1 minus x squared divided by 3 factorial plus x power 4 divided by 5 factorial minus x power 6 divided by 7 factorial, and so on. So this term inside the brackets almost looks like some familiar function, but it's not quite. There's something we can do to arrive at that particular function. Remember that there's a series for sine x is given as x minus x cubed over 3 factorial plus x power 5 over 5 factorial minus x power 7 over 7 factorial, and so on. But in our case, we are having 1 minus x squared over 3 factorial plus x power 5 minus x power 6. So we only need to multiply by x to make it the sine series. But if we multiply, we just multiply. If we just multiply by x, we'll be altering our solution. So what do? We multiply by x and then divide by x. In other words, you are multiplying by a clever one. So if you multiply by x divided by x, which is equal to 1. So the x in the numerator, you split it, you distribute it to the series, the power series inside the brackets. We are having root x divided by root 2 times 2 divided by root pi. Then we want to multiply this by x over x. into brackets 1 minus x squared over 3 factorial plus x power 4 divided by 5 factorial minus x power 6 divided by 7 factorial, and so on. So this is square root of x divided by square root of 2 times 2 divided by square root of pi times 1 over x. I want to distribute the x in the numerator. So x times all the terms, x times 1 is x. X times x squared over 2 is x cubed over 3 factorial. X times x power 4 is x power 5 over 5 factorial. X times x power 6 is minus x power 7 over 7 factorial, and so on.